Hello everyone, my name is Pranav Teja. I welcome you all to my PPT presentation. I am I am CSM branch first year. My subject is chemistry. I am going to present a PPT from the subject chemistry, and I hope you will enjoy this PPT, my PPT presentation. And let's get started. The topic for my PPT presentation is hot lime soda process. That this is one of the topic. This is one top. This is the topic that I have chosen for my concept video, and I hope you will enjoy my PPT presentation. Let's discuss what is this hot lime soda process. Before getting into hot lime soda process, first we need to know what lime soda water softening process is. There are two types in it. That the first one is cold lime water processing, and second one is hot lime soda processing. First, let's know what is lime soda water softening process. Soda lime is a process used in water treatment to remove hardness from water. This process is now obsolete but was very useful for the treatment of large volumes of hard water. Addition of lime CaO and soda Na2CO3 to the hard water precipitates calcium as the carbonate and magnesium as its hydroxide. The amounts of the two chemicals required are easily calculated from the analysis of water and stoichiometry of the reactions. The lime soda uses lime CaOH taken twice and soda ash Na2CO3 to precipitate hardness from solution. This is the diagram for of soda lime water softening process. Carbon dioxide and carbonate hardness. Calcium and magnesium bicarbonate are complexed by lime. In this process, calcium and magnesium ions are precipitated by the addition of lime, CaOH taken twice, and soda ash, Na2CO3. Now let's look at the chemistry of precipitation softening. In almost every raw water supply, hardness is present as calcium and magnesium bicarbonate, often referred to as carbonate hardness or temporary hardness. These compounds result from the action of acidic carbon dioxide laden rainwater or on naturally occurring minerals in the earth, such as limestone. For example, CO2 plus H2O is equals to H2CO3. That is carbon dioxide plus water is equals to carbonic acid. Another example is H2CO3 plus CaCO3 minus is equals to CaHCO3 taken twice. That is carbonic acid plus calcium carbonate is equals to calcium bicarbonate. Hardness Hardness may also be present as a sulfate or chloride salt, referred to as non-carbonate or permanent hardness. These salts are caused by mineral acids present in rainwater or the solution of naturally occurring acidic minerals. The significance of carbonate or temporary hardness as contrasted to non-carbonate or permanent hardness is that the former may be reduced in concentration simply by heating. In effect, heating reverses the solution reaction. CaHCO3 taken twice plus heat is equal to CaCO3 plus H2O plus CO2. That is, calcium bicarbonate, if it is heated, it results into calcium carbonate plus water plus carbon dioxide. Reduction of non-carbonate hardness, by contrast, requires chemical addition. A combination of lime and soda ash along with coagulant and flocculant chemicals is added to raw water to promote a precipitation reaction. This allows softening to take place. I hope you are getting what I am reading. Now I am going to repeat this slide and once again because this is very important because it is used. This is the harness that we are going to filter out from the using the lime soda process. So hardness may also be present as a sulfate or chloride salt, referred to as non-carbonate or permanent hardness. These salts are caused by mineral acids present in rainwater or the solution of naturally occurring acidic minerals. The significance of carbonate or temporary hardness as contrasted to non-carbonate or permanent hardness is that the former may be reduced in concentration simply by heating. In effect, heating reverses the solution reaction. CaHCO3 taken twice plus heat is equal to CaCO3 plus H2O plus CO2. Reduction of non-carbonate hardness by contrast requires chemical addition. A combination of lime and soda ash along with coagulant and flocculant chemicals is added to raw water to promote a precipitation reaction. This allows softening to take place. Now we will discuss what is cold lime softening process. Precipitation softening accomplished at ambient temperatures is referred to as cold lime softening. When hydrated lime CaOH taken twice is added to the water being treated, the following reactions occur. CO2 plus CaOH taken twice is equals to CaCO3 plus H2O. That is, carbon dioxide plus calcium hydroxide is equals to calcium carbonate plus water. CaHCO3 taken twice plus CaOH taken twice is equals to 2CaCO3 plus H2O. Bicarbonate plus calcium hydroxide is equals to calcium carbonate plus water. HCO3 taken twice plus 2CaOH taken twice is equals to MgOH taken twice plus 2CaCO3 plus 2H2O. That is magnesium bicarbonate plus calcium hydroxide is equals to magnesium hydroxide plus calcium carbonate plus water. Now, non-carbonate or permanent calcium hardness, if present, is not affected by treatment with lime alone. If non-carbonate magnesium hardness is present in an amount greater than 70 pp and an excess hydroxy alkalinity of about 5 ppm is maintained, the magnesium will be reduced to about 70 ppm, but the calcium will increase in proportion to the magnesium reduction. If the proper chemical control is maintained on lime feed, the calcium hardness may be reduced to 35 to 50 ppm. Magnesium reduction is a function of the amount of hydroxide alkalinity excess maintained. Figures 7.1 and 7.2 shows these relationships. Now I am going to repeat this again. Non-carbonate or permanent calcium hardness, if present, is not affected by treatment with lime alone. If non-carbonate magnesium hardness is present in an amount greater than 70 ppm and an excess hydroxyl alkalinity of about 5 ppm is maintained, the magnesium will be reduced to about 70 ppm, but the calcium will increase in proportion to the magnesium reduction. If the proper chemical control is maintained on lime feed, the calcium hardness may be reduced to 35 to 50 ppm. Magnesium reduction is a function of the amount of hydroxyl alkalinity excess maintained. Figure 7.1 and 7.2 shows these relationships. Now comes warm lime softening process. The warm lime softening process operates in the temperature range of 120 to 140 degree Fahrenheit, 49 to 60, that is 49 to 60 degrees Celsius. The solubilities of calcium, magnesium and silica are reduced by increased temperature. Therefore, they are more effectively removed by warm lime softening than by cold lime softening. This process is used for the following purposes: to recover waste heat as an energy conservation measure. The water to be treated is heated by a waste stream such as boiler blowdown or low pressure exhaust steam to recover the heat content. To prepare feed to a demineralization system. The lower levels of calcium, magnesium, and especially silica reduce the ionic loading on the demineralizer when warm lime softening water is used rather than cold lime softening water. This may reduce both the capital and operating costs of the demineralizer. However, most strong base anion resins have a temperature limitation of 140 degrees Fahrenheit, that is 60 degrees Celsius. Therefore, additional increases in temperature are not acceptable for increasing the effectiveness of contaminant reduction. To lower the blowdown discharge from cooling system, cooling tower blowdown may be treated with lime and soda ash or caustic to reduce calcium and magnesium levels so that much of the blowdown may be returned to the cooling system. Silica levels in the recirculating cooling water are also controlled in this manner. In any warm lime or warm lime soda ash process, temperature control is critical because temperature variations of as little as 4 degrees Fahrenheit per hour, that is 2 degrees Celsius per hour, can cause gross carryover of the softener precipitates. Now here comes the main topic that this video is all about. This PPT is all about. That comes here is the main topic: hot process softening process. Hot process softening is usually carried out under pressure at temperatures of 227 to 240 degrees Fahrenheit, that is 108 to 116 degrees Celsius. At the operating temperature, hot process softening reactions go essentially to completion. This treatment method involves the same reactions described above, except that raw water CO2 is vented and does not participate in the lime reaction. The use of lime and soda ash permits hardness reduction down to 0.5 grams per gallon or about 8 ppm as calcium carbonate. Magnesium is reduced to 2 to 5 ppm because of the lower solubility of magnesium hydroxide at the elevated temperature. Here is the diagram of hot lime soda process. This is the diagram. Here the raw water feed inlet, and this is the superheated steam inlet. Over here, the reaction tank is this. These are the chemicals, that is lime plus soda feed inlet. Chemicals like lime and soda comes from this inlet. Second one is conical sedimentation tank. This contains precipitated sludge, that is CaCO3 and MgOH taken twice. This outlet here down here is precipitated sludge outlet. This is the softened water that comes to this container, which contains coarse sand layer and gravels layer, fine sand layer, sand filter, filtered softened water outlet. Now I will explain. I'm gonna read this again. Hot process softening is usually carried out under pressure at temperatures of 227 to 240 degrees Fahrenheit. That is 108 to 116 degrees Celsius. At the operating temperature, hot process softening reactions go essentially to completion. This treatment method involves the same reactions described above, except that raw water CO2 is vented to and does not participate in the lime reaction. The use of lime and soda ash permits hardness reduction down to 0.5 gram per gallon or about 8 ppm as calcium carbonate. Magnesium is reduced to 2 to 5 ppm because of the lower solubility of magnesium hydroxide at the elevated temperatures. Now let us look at the advantages of lime soda process. It is very economical. If this process is combined with sedimentation with coagulation, lesser amounts of coagulant shall be needed. The process increases the pH value of the treated water, thereby corrosion of the distribution pipes is reduced. Besides the removal of hardness, the quantity of minerals in the water is reduced. To a certain extent, iron and manganese are also removed from the water. Due to alkaline nature of treated water, amount of pathogenic bacteria in water is considerably reduced. Now coming to the disadvantages of lime soda process. For efficient and economical softening, careful operation and skilled supervision is required. Disposal of large amounts of sludge, that is insoluble precipitate, poses a problem. However, the sludge may be disposed of in raising low-lying areas of the city. This can remove harness only up to 15 ppm, which is not good for boilers. Here are the advantages of lime soda process and disadvantages of the lime soda process. I am going to repeat this slide again. Once again, I am going to read for you people. The advantages are it is very economical. If this process is combined with sedimentation with coagulation, lesser amounts of coagulants shall be needed. The process increases the pH value of the treated water, thereby corrosion of the distributed pipes is reduced. Besides the removal of hardness, the quantity of minerals in the water is reduced. To a certain extent, iron and manganese are also removed from the water. Due to alkaline nature of the treated water, amount of pathogenic bacteria in water is considerably reduced. Disadvantage of lime soda process. For efficient and economical softening, careful operation and skilled supervision is required. Disposal of large amount of sludge, insoluble precipitate, possesses a problem. However, the sludge may be disposed of in raising low-lying areas of the city. This can remove harness only up to 15 ppm, which is not good for boilers. Here comes the end of my PPT presentation. I hope you all enjoyed it. I hope you have understood what is lime soda process is and how do we filter the waste, that is hardness of the water by this process. What are the cold water lime soda process and hot lime soda process and warm lime soda process as well. Uh, However, the hot lime soda is preferable because it is more efficient and it it increases the efficiency of filtration of hardness from the water. That is, water softening is done better in hot lime soda process rather in cold lime soda process. So that's the end of this PPT presentation. I hope you all people enjoyed and understood what this is about. Thank you. I thank you all people for giving your valuable time for my PPT presentation. And that's it. I thank you everyone, the teachers, students, and my friends, and everyone for your valuable time on this. I thank you once again. I thank you. Thank you. Thank you. Thank you. Thank you.